Sample 8. Water flows from a large tank through an orifice 75 mm in diameter and against a block as shown in the figure. The water jet strikes the block at the vena contracta. The block weighs 223 newtons and the coefficient of friction between the block and the floor is 0.57. The coefficient of discharge is 0.6 and its coefficient of contraction is 0.62. What is the minimum height y to which water must rise in the tank in order to start the block moving to the right? What is the rate of discharge through the orifice? And what is the velocity of flow? So help analyze the problem. Here is the given figure. And the weight of the block is 223 newtons. So the normal reaction would also be 223. Then the force, dynamic force, supposedly is denoted by F, Q rho times V. And the frictional resistance must be equal to that, 0.57 times 223. So F is Q rho V, or 0.57 of 223. I'll use this formula because the other formula, density area should be area at the vena contracta for that case, then velocity square, the actual velocity also. So I use this formula where Q is kaotog, where head is small h, then density times velocity c sub v square root of 2gh. Take note that coefficient of velocity is equal to coefficient of discharge divided by coefficient of contraction. So simplifying, 0.6 times pi 0.0375 square, the radius 0.0375 meters square. Then we have square root of 2gh, square root of 2gh, so that's 19.62h. Density is 1000. Coefficient of velocity is coefficient of discharge over coefficient of contraction, equals 127.11. So we can now solve for h. H is 2.526 meter. Therefore, y is 2.526 plus 0.3. So y is 2.826 meters. What is the rate of discharge through the orifice? It is just this part, kaotog. So 0.6 times pi 0.0375 square root of 19.62 times 2.526. So the discharge is 0.01866 cubic meter per second. Then the velocity is c sub v square root of 2gh, where c sub v is 0.6 over 0.62, c over c sub c, and 19.62 times 2.526. So the mean velocity of flow, the velocity is 6.813 meters per second.